Okay, this is VESPR part 2, so we're going to do some of the others now. So AX3E. So A is bonded to 3 atoms, so it's got 3 bonding pairs and 1 lone pair of electrons. So it has a total of 4. So its electron pair geometry is going to be tetrahedral. So I'm going to put my lone pair of electrons up here. My X is down here. So when we draw molecular geometry, A is the highest atom. We have 3 X's, so what we end up making is a triangle-based pyramid. With A at the top. So this is called trigonal pyramidal, or trig pyramidal. And an example of this is ammonia, NH3. Okay, moving down the page, AX2E2. So we've got 2 bonding pairs, 2 lone pairs for a total of 4. So I'm going to put my bonding pairs. So it's the tetrahedral shape for your electron pair geometry. I'm going to put my X's over here, my lone pairs over here. Don't forget they're 2 pairs. So if you look at the A and just the X's, we end up with a bent shape again. So the electron pair geometry is tetrahedral for 4, but the molecular geometry is bent or V-shaped. And an example of this would be dihydrogen sulfide, H2S. Okay, AX4E. Okay, AX4E, we have 4 bonding pairs, 1 lone pair for a total of 5. So this is going to be based on the trigonal bipyramidal model of AX5. So it does matter where we put our lone pair. So it's going to be in this equatorial plane first. So there's our 4 X's. So this is trigonal bipyramidal for electron pair geometry. But the shape that ends up remaining is this for molecular geometry, and if you turn it on its side, basically you have what we call a seesaw. It's called a seesaw shape, like a teeter-totter. And an example of this is TeCl4. AX3E2 has 3 bonding pairs, 2 lone pairs, for a total of 5. So this is also based on the trig bipyramidal. So again, we're going to put in our bonds. So the pairs of electrons go into the equatorial plane again, putting them in these 2 positions just for convenience. And then the others are x's. So again, this is trigonal bipyramidal as well for electron pair geometry, but for molecular geometry, for the one that we want, it's called T-shaped because we make the shape of a T. An example of this is bromine trifluoride. So we're going to move down a little bit more, do AX2E3. So we've got 2 bonding pairs, 3 lone pairs for a total of 5. So again, we have a shape that's based on the trig bipyramidal. So this time all 3 lone pairs go in the equatorial plane. So again, this is trig bipyramidal for electron pair geometry, but for molecular geometry, it's going to be back to linear. An example of this is xenon difluoride. Okay, hang in there, just 2 more to do. So we have AX5E, 5 bonding, 1 lone for a total of 6. So our electron pair geometry is going to be based on the octahedral shape. So this time I'm going to put my lone pair of electrons at the bottom. So this is octahedral in shape for electron pair geometry, but for the molecular geometry, it basically becomes, it's a very bad wedge, a square based pyramid. So it's a square-based pyramid. So it's square, pyramidal, instead of trigonal pyramidal. It's not a triangle base. It's square base. So it's a square pyramidal. And an example of this. Okay, last one. 4 bonding pairs, 2 lone pairs for a total of 6. Again, octahedral. Our lone pairs are going to be as far apart from each other as they possibly can. Again, the electron pair geometry is octahedral, but our molecular geometry is basically going to be just the base of our previous pyramid here. So it is just square planar. So it's all in one plane, square planar. An example of this is xenon tetrafluoride. So there we go. There's your basic VESPR shapes.